Okay, continuing with our example over here, let's go take a look at our picture again, and we're going to recognize something very important. We don't actually have theta. It was never actually given to us as part of the original problem. So we have to do something about this theta. So let's see if we can look back at our picture and do anything about it. Well, so we look at our original picture here and we notice something. We're using theta in terms of cosine and sine, and this theta is inside of a right triangle, or two right triangles. So we can go ahead and use the trigonometric relations for a right triangle here. So let's take this triangle over here and draw it out of context. And you'll see which triangle I am referring to here. Where this point at the top is our point A, and this length is 2A, this length is also 2A, and this length is A times the square root of 5. That length is A times the square root of 5, hence isosceles triangle. These are two 90-degree angles. That is theta, and that is theta. We realize that if we consider one of these triangles, let's just look at, say, any one of these two right triangles, that cosine of theta is defined as A divided by A times the square root of 5. And likewise, sorry, let me rephrase. Made a mistake. Cosine of theta is basically 2A over A times the square root of 5, and sine of theta is basically A over A times the square root of 5. And we see that A and A are going to cancel in numerator and denominator. So we can write this expression for cosine and sine respectively as 2 over the square root of 5 for cosine and 1 over the square root of 5 for sine. So let's go plug these guys in here. So we see k over a squared multiplied by q1 times 2 over the square root of 5 minus q2 times 2 over the square root of 5. Now both of those are in common, so I could factor those out and say, okay, k or 2k over a squared times the square root of 5 multiplied by q1 minus q2 is equal to the sum of the electric fields in the x direction at point A. So likewise, I can do the same thing over here. I can say for this one, this is going to be k over a squared times the square root of 5 multiplied by q1 plus q2. Here you're gonna plug in the magnitude of those charges in here. So now we see this is the sum of the electric fields in the y direction. Alright, so we have a lot of stuff in here that is in common. So let's go ahead and try to simplify our entire vector now. So let's take a step back and recollect that this is what our original vector is equal to in terms of I and j components. So let's write out this entire vector, and we'll do so in another video while also examining how to work with this result and looking at some hypotheticals.